Okay, so this is 1.32 our planet, so the answers to your practice booklet that you will be doing in the classroom. So nice easy image to kind of get started, looking at where the mantle core and crust are. Okay, sometimes you get an inner core and an outer core, but that was a nice easy question to get started. Fill in the gaps in these sentences. The Earth is almost a sphere and is made up of several layers. The crust is the thin layer of solid rock. The core is at the centre of the Earth. The mantle is mostly solid, but deep down it can flow like a liquid. Explain why this is. Convection currents cause it to move. Does the mantle flow quickly or slowly? Slowly. What is the name of the part of the Earth that we live on? That's the crust. Scientists think this layer is made of iron and nickel. That is the core. Moving on then, looking at a pie chart of the present day Earth atmosphere. This gas here, 78% is nitrogen, 21% is oxygen. Them numbers change slightly, but they're good numbers to remember in terms of what you get in our atmosphere. Roughly, what was the percentage of carbon dioxide? 0.04. Anything below 1 would have been fine. Name another gas. Methane. You could have had argon, helium. Could have said water vapour. There are lots of different gases you could have said. Write down 2 examples when humans burn fossil fuel: driving, using electricity. Explain how greenhouse gases keep the Earth warm. They get stuck in the ozone layer. Okay, so the ozone layer is what protects us so that when the sun shines in, it kind of bounces the sun back off, so the rays, the harmful UV rays don't get to us, okay? But a certain amount of the sun will obviously go through to keep us warm, but not all of it. Most of it will bounce back through and go back. But what happens is a little bit gets stuck because of the CO2 layer, and all that gets stuck within the CO2, okay? What has happened to the carbon dioxide level in the atmosphere? It is increasing. Lovely then kind of question looking at the structure of the periodic table. Give a name of an element in group 6. You could have named any of these, okay? Oxygen and sulfur are the most obvious ones. Give the chemical symbol of an element in group 2. So again, calcium, beryllium, magnesium, barium, so some nice easy ones there. Give the name of an alkali metal, it labelled it for you. So lithium, sodium, potassium are the big ones for you. Halogen, again, they labelled them: fluorine, chlorine, bromine. Noble gas, helium, neon, argon, the big ones that you would know. In which group would you find boron? And they said it was a B, okay? So it's group 3 at the top there. In which group would you find cesium? Group 1. Krypton, group 0 or group 8. What type of element is bromine? It's over here. It's a halogen. Potassium is an alkali metal. Neon is a noble gas. So it was helping you label them there. Then it asks you if these elements were metals or non-metals. So Mg is there, so it's a metal because anything this side is a metal. Se then is by there, so it's a non-metal, and then Ra is over here, so it's a metal. Okay, these ones kind of either side, okay, I've got properties of metals and non-metals, so they're a little bit weird. When 2 elements combine, they usually end up with the name in IDE, and there's a nice little simple rules for you to read through and look up there. When 2 or more different elements combine and one of them is oxygen, the ending will normally end up as 8. Give 2 examples of 8, so copper carbonate, iron sulfate. Then kind of matching them up, so water looks like that, iron oxide looks like that, encouraging you to think about what the chemical symbols would be. Give the name and formula of the molecule, so it's 2 F's, so it's fluorine. Why is it a molecule and not a compound? Because they're the same element. And give 2 other elements almost always are never found as single atoms, okay? So what it is, it's the 7 on the periodic table. So you've got nitrogen, you've got oxygen, and then you've got like fluorine, chlorine, bromine going down there. Okay, they're the big 5 you kind of remember, and hydrogen, which doesn't fit in the 7. Information about crude oil, it gave you the keywords to use, which was quite nice. So crude oil is heated and fed from the bottom of the fractionating tower. Because crude oil is very hot, the hot liquid evaporates to form a vapour. The fractionating column is hotter at the bottom than it is at the top, so the temperature decreases as you move up the column. The water vapour condenses. The liquid that is formed is then removed. The temperature at which the water vapour condenses is the same as its boiling point. Up the fractionating column, the boiling point decreases, the size of each molecule decreases. Crude oil is finite, so it will eventually run out. And then looking at different properties, so as you trend the property as the carbon chain length increases, the boiling point also increases. Viscosity, so like if it's runny or not, that's what viscosity means, decreases, and so does flammability, which means the ability to start a fire also decreases. So looking at monomers, then drawing a line, really easy. You're looking for the same compound, just with the double bond removed, okay, to form its polymer, and you put it in a little square bracket, straighten it up, okay. Then it was asking you to look at each polymer and work out what they're used for. So this is PVC because it's got the chlorine, and that's used to make window frames. This is the main one, polyethylene, the main one we use for plastics, packaging, and then this one's for non-stick frying pans, okay. So there are some basic advantages to any type of plastic. This was like a 6 marker. They're light, transparent, it's just cut off where I've cropped it. Non-toxic, easily coloured, waterproof, and do not break, okay. Disadvantages are they're non-biodegradable, relies on crude oil to be made, which is a finite resource, causes litter, need for landfill sites to need more space for them, which can ruin habitats to make more space for landfills, and they form toxic gases when burnt, okay. So there are some disadvantages, but obviously plastic is used every day, and there are quite some large advantages too. Write the word equation for what's happening. So you've got aluminium plus iron oxide. So that's our reactants by here. Aluminium is higher up, so it's going to become aluminium oxide plus iron. Okay. Aluminium is more reactive than iron. It will displace the iron in the ore. Okay. What would be different if we use copper and aluminium oxide? There'd be no reaction. Copper is less reactive than aluminium, so nothing would happen. Looking at the blast furnace then, the 3 more materials of the blast furnace, you had to pick them from here. So you've got iron ore, coke, and limestone. Project B, because slag always comes out on top. And then C would be the actual iron, is what you're trying to make in the blast furnace. Okay. Underline the element that was removed from iron oxide would be oxygen. And then it says, choosing from the words above, which is quite a nice question. What is that kind of setup there called? It's electrolysis. And then copper chloride leaves a solution by electrodes, which are these bits by here. Be careful not to miss a mark here. So copper goes to the negative, chlorine goes to the positive, wrong way round with the charges. Okay, that little E there then represents the electrons, and the solution will get paler. And what gas is formed at the anode? You've drawn the arrow, it's going to be chlorine.